Good morning. Today we are going to start new chapter, chapter 13, unit 13, hydrocarbons. In that one topic is there, that conformation in alkane. So this conformation is a part of the hydrocarbon. So today we are going to study conformation in alkane. So what is conformation? So this is alkane. In alkane, this carbon-carbon bond is there. Carbon-carbon single bond is there. This rotation in C-C bond is almost free. Just to see, this alkane is there. This rotation is almost free. Why is it almost free? Because some repulsive interaction will be there between the bonds of the adjacent carbon atom. These electron clouds are they will repel to each other. So that's why the rotation in C-C bond is almost free, not completely free. Energy barrier is there. Energy barrier is 1 to 20 kilojoule per mole. And this energy barrier, because of this repulsive interaction. So what is repulsive interaction? The repulsive interaction between the bonds of adjacent carbon atoms. The repulsive interaction between the bonds of the adjacent carbon atom. And this repulsive interaction is called torsional strain. This repulsive interaction is called the torsional strain. So as I told you, the rotation about the C-C bond is not almost free. Why it is not completely free? Because repulsive interaction is there. So when you rotate it like this, many structures are possible. Infinite number of momentary element of atom in space are possible, and these momentary element of atom in space, that is called conformation. So due to free rotation in C-C bond, in alkanes, infinite number of momentary arrangement of atoms to the free rotation in C-C bond will take infinite number of momentary arrangement of atoms in space are possible. These arrangements are called conformations. These arrangements are called conformation. Rotamus, conformation. So these infinite number of momentary elements in space you are getting, it is called conformation. What is torsional strain? The repulsive interaction between the bonds of the adjacent carbon atom is called torsional strain. So now we are going to take that conformation of ethane. So next one is conformation of ethane. structure of ethane. In ethane, this molecule this one is ethane. In ethane, just you see, one carbon atom is kept fixed, then another one is rotated. One arrangement, another arrangement, another. Like this, infinite number of rotated elements of atom in space you will get. So regarding this ethane, infinite number of conformations are possible, but only two are the important. Two extreme cases are important, and these two extreme cases are staggered and eclipse. So in ethane molecule, in ethane molecule, one carbon atom is kept fixed and other carbon atom is rotated through C-C bond. Infinite number of conformations, are possible. Out of these conformations, two extreme cases are important. Two extreme cases are important. What two extreme cases are there? Staggered, and second one is eclipse. So just to see what is staggered and eclipse. So this carbon is there in the carbon atom. One carbon atom is kept fixed, other one is rotating. So between these two bonds, repulsive interaction will be there. So in the staggered conformation, these two carbon atoms is arranged like that. So these hydrogen atoms are in the maximum distance. So here the repulsive interaction will be minimum. But just you see in this situation, both the carbon atoms like this, both hydrogen atoms are just like the superimposable positions. So here the minimum distance is there. So in this eclipse conformation, the distance in the two adjacent hydrogen atoms will be minimum. So repulsive interaction will be maximum. So if you compare, you will see the stability that staggered will be the more stable. So two extreme cases are important: staggered and eclipsed. Staggered conformation, and eclipsed conformation. So which one is staggered and which one is eclipsed? So first of all, about the staggered conformation. In staggered conformation, the hydrogen atom of the adjacent carbon atoms. In staggered conformation, the hydrogen atoms of adjacent carbon atoms are at the more stable. Then next one is in eclipse conformation. In eclipse conformation, the hydrogen atoms are adjacent carbon atoms. The hydrogen atoms of adjacent carbon atoms are at the minimum distance. So the repulsive interaction is maximum. So the repulsive interaction is maximum. Hence it is less stable. So between staggered and eclipse, staggered is more stable. Now next one is the representation of conformations of ethene. How we can represent? So there are two methods for the representation of conformations of ethene, that sawhorse projection and Newman projection. So representation of conformations of ethene. Representation of conformation of ethene. Representation of conformation of ethene. Two methods are there. First one is sawhorse projection. Second method is Newman projection. So just you see this ethane molecule is there. This ethane molecule in sawhorse projection, we see this molecule through the oblique angle. In sawhorse projection, we see the molecule in oblique angle. So this situation will be there. This carbon, 3 hydrogen atoms are attached. With that carbon, 3 hydrogen atoms are attached. Just you take, if you take this carbon and you keep here, this hydrogen atom will be at the maximum distance. So this one is staggered. Another one is if you take this carbon and you keep here, then hydrogen atom will be at the minimum distance, and this one is eclipse. So this one is called sawhorse projection. Now this is the front carbon atom. This is the front carbon. That carbon is the rear carbon. In Newman projection, the front carbon is represented. Front carbon is represented by the center of the circle. And the rear carbon means back carbon. Rear carbon is represented by the circumference of the circle. this one is staggered. Then another one is this is the front carbon atom. The rear carbon atom is this one, represented by the circumference of the moon. Another one is represented by circumference, this one. So this will come here. This one is eclipse. And this type of representation is called Newman projection. This one is Newman projection. And both the forms are interconvertible. If you rotate through 60 degrees, then staggered will be converted to eclipse and eclipse will be converted to staggered. Means only the 60 degree. Now the relative stability are the conformation of ethane. Which one is more stable? Relative stability of conformation of ethane. Relative stability of the conformation of ethane. Relative stability of conformation of ethane. Just now you have seen that two extreme cases are important. Many conformations are there. So two extreme cases are important. That staggered and eclipse. So energy of molecule, angle of rotation through C'(C) bond. So this 0, 0 is there. Like this will be going. So this one is 0, 60 degree, then 120, here 180, like this will be going. This one is the lower energy is there, and this energy barrier is 12.5 kilojoule per mole. This one is staggered. This one is staggered. And here the high energy is there. Here eclipse will be formed. Then here like this. So eclipse and staggered both are interconvertible by the angle of the 60 degree. If you rotate 60 degree, then eclipse and staggered both are interconvertible. Now just to see the stability, which one is more stable? So this is the situation. This one is staggered. So in the staggered form, the distance in the hydrogen atom is maximum. So that's why it is more stable. But in eclipse, they are the minimum distance like this. This is the situation. So in this one, the hydrogen atom of the adjacent carbon atoms, they are at the minimum distance. So repulsive interaction is more here, maximum is there. So it has the more energy, it will be less stable. So between staggered and conformation, staggered form is more stable. Staggered form is more stable than the eclipse conformation. The reason is given that in staggered conformation, the repulsive interaction is minimum. Staggered conformation is more stable than eclipse conformation because repulsive interaction means torsional strain. Staggered conformation is more stable than eclipse conformation because repulsive interaction is minimum in staggered conformation. And the energy barrier is 12.5 kilojoule per mole. This energy is not large enough. This energy is not large enough to prevent ethane molecule to remain in the form of staggered conformation. In the form of staggered conformation. At the room temperature, molecules get sufficient energy by thermal motion. So both the forms are interconverted. So both the forms are interconverted. So ethane molecule will try to remain in the form of the staggered conformation, but this energy barrier is very small. So by molecules at the room temperature, their thermal motion is there, you will get a sufficient energy. So they will be converted. In eclipse, and eclipse will be converted to staggered. And both the forms are interconverted by the degree of rotation only 60 degrees. So you go through your book, page number 824. Just you underline something. In an alkane, there is a freedom of free rotation about the bond axis. The free rotation around the bond axis results in a large number of the different spatial arrangement of atoms or groups attached to the carbon atom. The different spatial arrangement obtained by the free rotation around the bond axis of the C-C sigma bonds are called conformers or rotamers, and the molecular geometry correspond to conformer is known as conformations. So alkane can have infinite number of conformations by rotation around C-C single bond. However, the rotation around C-C single bond is not completely free. because the rotation is hindered by the small energy barrier 1 to 20 kilojoule per mole due to weak repulsive interaction between the adjacent bond. This type of repulsive interaction is termed as torsional strain. So conformation of ethane, here you can underline that page number 825, energy level figure is given. Below that you can mark the stability of conformation thus depends upon the repulsive interaction between the electron clouds. This repulsive interaction is called torsional strain. The magnitude of torsional strain depends upon the angle of rotation about C-C bond. This angle is called dihedral angle or torsional angle. Important for you, this angle is called dihedral angle or torsional angle. The staggered form of ethane has the least torsional strain, whereas the eclipsed form the maximum torsional strain. This is why of all the conformation of ethane, the staggered form is most stable and the eclipsed form is the least stable. So you have seen that in staggered and eclipse, staggered form is more stable because repulsive interaction is minimum, and eclipse form is least stable, less stable because repulsive interaction is maximum. So in the next video we will study that preparation of hydrocarbon.